Okay, so what are some examples of the badnesses that high schools have been perpetrating on you to to leave you so sort of stunned at what's going on in university, so unprepared, as most people are, like I say, including myself when I was a first year student many years ago. Um, One of them, so this is in trig. One example is actually two examples. So one area of math in which we have two examples is trigonometry, where in high school they give you stuff like trig tables. So, and you might have seen stuff like this, right? We have sine, cos, tan, cosecant, secant, cotangent, etc. Then we have 0, 30, 45, 60, 90, and then the radian measures of these things. And sometimes they do a lot more angles than these, right? They get multiples of 30, 60, 90, 45, etc., pi over 6, pi over 4, pi over 3. And so these tables get gigantic, and they either tell you to memorize them, or more commonly, they just give them to you on tests. And literally, so they'll be testing you on something we need to find like sine of pi over 6. And you'll go and find, okay, this is pi over 6. We go down here to sine, and it's 1 over 2. You look it up in the table, you write the number down. You haven't learned anything, you don't understand anything, but you got the right answer. This is the disguising non-performance. And of course, these things are basically meaningless to you, right? You may as well be memorizing a cookie recipe or looking up, something in an index somewhere, right? It just has no connection to the math. You haven't learned anything. And so they don't do this again. They do not do this in university. What we are expected to do in university and what we in fact learn how to do, we learn to use these two core tools, and then we can solve any of these very, very quickly and very, very easily without having to go to a table. And it could be any multiple of any of these. If I said find negative 107 pi over 6, find sine, cos, tan, cosecant, cotangent, tangent, or which one did I forget? Secant, of negative 107 pi over 6, right? You can find that like this instantly if you know, or in a few seconds, if you know how to use these things, right? So this is the learning, understanding, getting the hang of these tools. This is the university way of doing it versus the high school way, which is you just don't learn anything. You look it up in a table, and it's basically legalized cheating, which is a lot of what they do in high school math. Another one is the cast rule. This is my favorite. This one is totally insane that they actually give people this and that people are using this in high school. The cast rule is telling you what, as I'm sure you've seen, whether cos, sine, tan, or all three of them, which of these are positive in which coordinate, in which quadrants, right? First, second, third, fourth. All this boils down to, so basically this is a unit circle. We're not going into this in detail here, but the cosine, the long and the short of it is the cosine is the x, the sine is the y, and tan is sine over cos. So of course cos is going to be positive when the x is positive. Sine will be positive when the y is positive, when we're above here. They're all going to be positive when the cos, the x, and the sine, the y is positive. Tan will be positive when cos and sine have the same sign. So basically, if you understand these basic fundamental things like cos is the x, sine is the y, the x is positive to the right of the y-axis and negative to the left of the y-axis. The y is positive above the x-axis and negative below the x-axis. The tan is sine over cos, and that negative divided by negative is positive. Negative divided by positive or positive divided by negative is negative. Positive divided by positive is positive. If you know these basic fundamental facts, you don't need this thing, right? So the fact that they're giving this to you means that they are not teaching you basic stuff, means they're not teaching you extremely fundamental stuff. They know that students don't know fundamental things, and they give you a cheating chart to help you get the right answer, even though you don't know it. And that's why people show up at university and crash and burn and have these horrible experiences, because they're making you think you know stuff when you don't know it. They're setting up for failure. It's really, really horrible. And if you detect a bit of bitterness in my voice, it's because this happened to me. I had a horrible, horrible time in high school. This exact same thing happened to me. Then I got to university, loved math, learned how to learn properly, which is again, it's a bit of a struggle. It's not easy. It's very challenging. But then you actually learn stuff. It's really, really cool. And you go into tests with complete and total confidence and then zero anxiety, which is a really, again, amazing, amazing experience. That's what does it to you, right? Memorizing stuff and hoping they give you tables and things like that. That is how your anxiety is constantly through the roof, hoping that you get the right answers, that, cherry picked the right questions. The cherry-picked questions to let you just kind of plug stuff in without having learned anything, right? That knowledge, that deep understanding, that is your safety net, that is your comfort zone. That is the thing that gives you that confidence and the lack of anxiety. Okay, next up is polynomial division. You might recognize this from MHF for you or whatever wherever you studied advanced functions. This is synthetic division, and this is a poster child for the badness of high school math teaching. Memorize some steps, take some numbers, push them around. These numbers, by the way, with polynomial division, we're dividing polynomials by one another. This is a polynomial. We're not, again, we're not going to do it. We're not going to go into detail here. We have videos on all of the things you need to do to divide polynomials. Rational roots theorem, the toolkit for this, right? The toolkit for trig is the special triangles in the unit circle. The toolkit for polynomial division is the rational roots theorem, the factor theorem, and then polynomial division. The way we're going to show you how to divide polynomials is this way, which emphasizes process understanding. We see at every step of the way why we know why we're doing what we're doing and why we're doing it. We know that every single step is correct, that we are correct up to there. We know how to verify our answer. As engineers, this is crucially important, being able to verify, to know that what you've done is right and be able to verify it and validate it so that the bridge doesn't collapse and kill everyone. And yet, in a high school, they are teaching you to do this step memorization way of math, where you take some numbers, you don't really even know what these numbers represent. This is the root, I think, but then you move it down here, you bring this one down, you multiply it, you move it up here, you add them. You have no idea. Again, this you could be just memorizing a cookie recipe, or steps for baking a cake or something like this, right? These things are as divorced from the actual mathematical objects that we're using them to understand and work with as a cookie recipe is, right? So understanding processes is what we are supposed to be doing. This is how we really learn. This is how we do well in math courses. This is how we become great engineers. Not we, because I'm not an engineer, but this is how I've seen that literally seen the people. This one out of everything is almost kind of a litmus test for who will be a great engineer versus who will maybe get through the program or have to drop out or something like this. The people who go for this, who say, I want to understand everything, I want to understand all the steps, hack into it and see inside the machine and know why it's working and know that it's giving me the correct output. Those people, I've been doing this for long enough that I've seen them graduate and get master's degrees and be patenting stuff and just changing the field of engineering that they're in because they wanted to understand stuff. The people who take the path of least resistance say, oh, I'll just push the numbers around, I'll get the right answer, will come out fine. You know, if they're lucky, they get through and they get a ring and they go out and do some jobs somewhere. But you know, they're not going to be top people, right? They're not doing master's programs. They're not patenting stuff. They're not, you know, having the big successful career and sort of impact in the world that you have this way. And again, the people generally the people who go for this, who go for the memorization. I don't want to say that like nobody graduates, but I've seen so many of them drop off over the years. Just, you know, not make it from first term to second term because they won't do this stuff. So we're going to see again how to understand processes, not memorize steps. Last one. I actually probably should have saved this one for last because this is the most dramatic one. But solving inequalities is another example. I wanted three examples. Comedy comes in threes. Things for impact come in threes. If this is the same polynomial from up there, actually, after we've factored it, if we want to solve the inequality where this thing is bigger than or equal to zero, we could build core skills like graphing, which is absolutely a core skill. It was one of the marking criteria in the 186T course I used to be a TA for, is just trying to get people to graph. It's a thing you were supposed to have learned to do in high school, but instead in high school, what do? They avoid the learning. Right? They avoid the learning. People struggle with graphing, and in high school, if you don't get something in 2 seconds, which is nothing in math, they give you a way to disguise the non-performance, right? They give you some trick or formula sheet or a technique, a sort of process that you memorize, an algorithm that you memorize that will get you the right answer if you apply it correctly, but it's very hard to apply things correctly when you don't understand them. This is actually one of the reasons that synthetic division, I've literally seen this marking quizzes in 186T. The people who do synthetic division, they get the answers badly wrong, and they don't have any idea that their answer is wrong because they're memorizing an algorithm that they don't understand. If you understand how to do it, if you understand what you're doing and why it works, you will know that you're right at every single step, and you start to see the numbers in the matrix. You do it the correct way enough times. Same thing is true with special triangles and unit circle. You start to see the solutions before you've done the problem just by with so much repetition and saturation in your brain. So I can look at these polynomials and say the factorizations and say this is obviously wrong, right? 0 marks, but they know. They think they know that it's right because they push the numbers around. They didn't see the mistake coming out, and so they get the wrong answer. And they always say, the people always say, oh, this one is quicker. First of all, it's not quicker. If you understand how to do this, it takes the same amount of time. But what is the benefit of doing it quickly if you A, don't understand anything, didn't learn anything, and B, got the answer wrong, right? It's really quick if we just give you the answer. You learn zero though. And this, you don't even get the right answer. So a lot of the time. And same thing is true of this. This is what's called a sign chart. We could learn how to graph a simple polynomial like this. This is a core skill, which everybody needs to have. But of course, in a high school, they avoid it. They say, okay, do this robotic mechanical process. Take the factors, put them down here. Take the numbers which make them zero, put them up there. And then on each interval, take a test point. Pick x is less than -3. X is in between -3 and -1, etc. Put in these pluses, minuses. See here we have three minuses. They make a minus when you multiply them, stuff like this, right? And we get these intervals. Or we could just say, okay, this is a cubic polynomial, positive leading coefficient, so the end behavior is up on the right, down on the left. These are the roots. Multiplicity is 1, so it crosses, goes through like this. In 5 seconds, you can have this thing and see it's positive here, positive there. I'm not saying that the speed is the thing that makes this good. The understanding is what makes it good. But on top of that, this is faster. If you really, really understand the deep concepts, right, then you can do less work with more understanding, less work, less writing, less sort of drudgery with more thinking, more understanding. So this is kind of the smart way to do it. If you can do things quicker by doing it intelligently, right, by doing it in a way that uses your understanding in your brain, that is fantastic, right? Doing it quicker by not thinking and not understanding anything is bad. So this is again an instance of it. This is, I guess, why I saved it for last. Probably, I don't know what's going on in my head, but this is one where you do less thinking and it takes longer and it's more error prone, right? Whereas if you don't avoid the core skill, then you'll have a much better time. And so this is one of the things that we talk about that we do a lot in the review sessions, in the videos, in the pre-exam and midterm review, is we actually teach you from scratch how to graph things, right? All of the ways that you should have been being taught in high school to prepare you for university, we teach you in the courses. And again, this is basically exactly what I was doing for the Faculty of Engineering over the summers, teaching that course for the people who were coming in. And wanted to get a jump on first year. And like I said, those people did extremely, extremely well. An anecdote I probably should have shared at the beginning was that I had this one student. This is my favorite one ever. One student, I was teaching this class, and it was on Zoom. It was online, and nobody had their cameras on, which is normal. I don't care, right? As long as you can see my screen, that's all that matters. But I didn't know if people were listening. I would rant and rant and rant about the university way of doing math and how you should be doing it. Deep understanding and drawing the little picture and proving everything and deriving everything. We're going to see how to do all of those things. I was telling them, do this, do this, do this, do this. I had no idea if people were listening to me, if they were gaming, if they were, just copying what I was doing, or I had no idea. That was the summer. So that was August, July, August. I would have been doing that. The next year, in the winter term, I was in Bayan, and for a different reason, and a student came and recognized me. I had a mask on. This is how long ago it was, but he recognized me and said, "Hey, you're Simon. You were teaching that course, weren't you?" And I said, "Yeah." And he said, "Thank you so much. I did all that stuff. He did all of the little things I was saying to do. Studied exactly the way I was saying. Do all of the derivations, prove everything. Have this way of remembering everything, of understanding it. Don't memorize anything, right? Prove everything up from scratch." He did all of that stuff, and he said first year was a breeze. 188 was a breeze, 186 was a breeze. He was in the middle of 187, and it was a breeze as well. He was having a fantastic, fantastic time getting great grades. So it's one of those things where you kind of like, everyone's seen those memes where the little stick figure has the easy path, but it leads to like a harder path, and the harder path leads to an easy path, something like this, right? Easy decisions, hard life, hard decisions, easy life, something like this, right? It's one of those where if you invest the time in understanding things properly, then you do have a really, really good time. You do much better and you have much less anxiety. And so this is what we do in the community and the videos and the review sessions. So hopefully you like that video. There's lots more to check out in the future videos, the further videos in the series. We actually go and learn how to do the special triangles, the unit circle, learn how to use those properly. Same thing with polynomial division, right? We practice what I'm preaching here. We actually learn in depth all of this stuff. And all of these are on the YouTube channel, but they're also on the school side. There are many more on the school side, actually. And the school site is also where depending on when you're watching this, if you're watching this before the term has started, then the review sessions will be beginning in the second week. So we have weekly review sessions of the previous week's material for MAT 186 and 188. Or if you're watching during the term, those have already begun. And there will be a midterm review session coming up. There's always multiples of those, right? So you can access those. And then the final exam, right? Big final exam review sessions, cumulative stuff that we do at the end of the term. So that is all through school. And again, if you don't want to type that in manually, you can see the link in the description, also the link to our website, and you can access the school website through that. So hopefully everyone enjoyed the video. And I will see you in the future ones. And hopefully we now understand what is happening in first year, why it's not your fault, and what we can do about it.